Test. Okay, so right now I'm not going to go through the rest of this, but I'll put it up here for you to look at. First I'll go to the exercises. Oh, by the way, if you want the references, here they are. And the exercises. So this is 1 through 5. Six through 11, and hands-on analysis. Now, let's look at the ones. Number 1 would be good. Number 2. Number 3. Number 4. Number 5 is good if you can explain it, but it's not necessary. Number 6. And number 7, that would be good to do. And this that refers to, I think it was video Neural Network Theory 4. I think that was it. And also the same thing for number 8 would be good to do. And number 9. And then the rest of them we didn't, 10 and 11 we didn't cover yet. Okay. All right, now let's just go, let me just give you the, just scroll through this in case somebody wants to read this particular section. So first of all, discussion of the learning rate. We talked about it, eta, and how large should the learning rate be. And here it says large eta may cause the algorithm to overshoot the global minimum. And you can read through this. This would be called the global minimum here. And then there's momentum. We didn't use momentum, but you can include momentum in this way. So you can change the formula for for delta W current to this formula, where you include a momentum term, which you call alpha. So you can check this out. And here, this shows the picture where the global minimum might be here. This is the smallest SSE. At this, you might get stuck here. So small momentum alpha may cause the algorithm to undershoot the global minimum. I can read about that. whereas greater momentum, which is shown by a larger ball, might cause you to overshoot the global minimum. And then sensitivity analysis. So here he talks about the fact that we don't know what are the important variables in our prediction. So we can employ something like sensitivity analysis, or I think discriminant analysis also, to try and figure out which variables are most important in making the predictions. So here, we conclude that the network is more sensitive to variation. Well, anyway, all right, skip that. Okay, here's an application of neural network modeling. So you can get this data from University of California Irvine Machine Learning Repository, and you can use Weka instead. He's using Insightful Miner, but you can try using Weka for this. And trying to predict whether someone has more or less than $50,000 income. This is the picture that we saw originally, or before. You can use Weka to try and do it. These are the weights, I guess, that the model generates. I'm not sure if you can get the weights from Weka or not. If anyone finds out how to do that, please leave a comment on our website. Some of the neural network weights for the income example. Here's the rest of the text here. They use Clementine for sensitivity analysis. I'm not sure what other software provides sensitivity analysis. I'm not sure. I don't think Weka does, but if it does, please let us know on the website. And I believe discriminant analysis would also be another approach, and you can try that on this problem. And okay. So this is an output from Clementine indicating that capital gain was one of the most important predictors of whether the income was, well, predictors of the income, and so on. Okay. And here are the references again. Okay, that's what we're going to do with neural networks.